Hello everybody! This video introduces the SynDat app, which is designed to create artificial data sets in an easy and effective way. When teaching data science, it was always time-consuming for me to find data sets that my students can relate to. In addition, the available data sets did not always behave well. Independent variables for regression analysis were either not significant or they even had the wrong sign. Available data sets were often outdated, too small, or not clean. This was the reason that I created SynDat, an app to generate synthetic data sets for learning and teaching. Let's have a look. Let us assume I want to create a real estate data set either for myself or for my students. A disclaimer, this is just a demo of SynDat. I would probably generate a slightly different data set if this would be a real application. So you start with going to the App tab. We leave the 500 observations for the data set at the default value. And SynDat assumes that we are generating data for a linear regression. If you want to generate data for another purpose, you just ignore or delete later on the dependent variable. Let us start with the dependent variable. I call it price for the house price. The mean is 600,000. And the standard deviation for the error term of my regression is 100,000. Each setting has its individual seed value. This allows you, if you're not happy with the outcome of the randomness, to change the seed value and you would get randomly similar but different values. Let us start with the first independent variable. I choose rooms. I change it from inactive to discrete because I want a discrete distribution. I call it here rooms. And I want 2 bedrooms all the way to 5 bedrooms, and the probability distribution should be 0.2 for 2 bedrooms, 0.3 for 3 and 4 bedrooms, and 0.2 again for 5 bedrooms. As a coefficient, I choose 100,000, and that means that my regression later on will generate a coefficient that is not exactly 100,000 because still some randomness is involved, but it will be close to 100,000. Now let's look at the other independent variables. I have filled out the fields ahead of time to save a little bit time. We have the condition index, which reflects which is the condition of the house. We use values between 0 and 100. The variable is normal distributed with a mean of 50 and a standard deviation of 30, which raises the question, what by accident, although unlikely, we get a value that is either smaller than 0 or greater than 100. In that case, the observation gets simply deleted. And that is no problem because we want 500 observations, but we generate 5,000. The program is fairly fast, so you can be generous. 50,000 wouldn't take much longer. And what happens? The observations that don't fit the minimum maximum criteria get deleted. And then from the remaining ones, 500 in this case are randomly chosen. The third variable here is a dummy variable. We again choose discrete. It shows if a house has a view or not. 0 is no view, 1 shows a view. And we assume here 90% of the houses don't have a view and 10% of the houses have a view. The approximate coefficient that we want for the regression is 30,000. Seed value again, 123. You can change that at any time. The last variable we want to consider is the year built. It is uniform distributed, so each year has the same chance. It's continuous. That means the months get coded as decimals. So the 1st of July of 1921 would be 1921.5. What I like to point out here, I chose a coefficient of 0. Whenever the coefficient is small and the standard deviation is big, the chance of having a significant variable with a low p-value is very low. Here I chose 0, so we should expect that this variable is not significant. I'm done, so I submit here. That takes a moment, and I save my results here as data results in my temporary folder. And I'm practically done. I could use the CSV file for my teaching. What I also can do is I can go here to test it to get some descriptive statistics and the first regression to see if my file really generates what it was supposed to generate. That takes a little bit because a full version of Python and pandas needs to be loaded. Here is it. I upload my file, data results, the one that I generated before. And then when we look at the descriptive data analysis, we can see here 500 records have been generated, and we can see that our variables are in the range that we want. Rooms is from 2 to 5. Our condition index that was supposed to be between 0 and 100 is between 0.38 and 99.82, and so on. We can also see our regression here, and we find that the coefficients are close to where they're supposed to be. The coefficient for rooms is about 100,000. The coefficient for condition index is a little bit higher, 650 instead of 500. The dummy variable view, yes, has a coefficient of 40,000, and you can see that your build has a very high p-value and therefore is not significant. This is exactly what we wanted. I go back to the app because I want to show you something else. As you can see, all our entries are still here and we can change them if we want to. When we generated the data set, all the independent variables were generated independently of each other. So in our data set, we do not have any systematic multi-correlation. But sometimes for teaching, you want some multi-correlation in your data set to demonstrate that problem. And a typical case is rooms and square footage when we work with real estate data. We have rooms already as our first variable, and now I override the non-significant variable year built with a new variable that is correlated to the first variable. Currently, I can only create a correlation to the first variable, but this will change in later versions. So I change the variable type here to correlate. I change the name to square feet, and we assume each room has about 400 square feet, so I choose 400 as a multiple here. I choose a standard deviation of 100. The bigger the standard deviation, the weaker is the correlation, and I choose a coefficient value of 240. Again, I submit, and again I save my data as data results. And now, when I go back to the Test It tab and I upload my results data set, I can see I get similar results. Even in the regression, here is my square footage, has a coefficient of 250. But now if I look at the multicollinearity results, I can see that rooms and square feet have a variance inflation factor that is beyond 10, which is usually the threshold to identify multicollinearity. I hope you find the SynDat app useful. Until next video, happy analytics.